Hi everybody. This is a video to go over the basics of how to use the average value calculation. If we want to calculate the average value of a function, f of x between a and b, we're going to use this particular calculation. Now, it looks a little scary. If we break it apart, we can see we've got our standard integral that we're going to use fundamental theorem on. So the integral from a to b of f of x and dx, that'll give the change, the total change of f of x between a and b. Multiplying by 1 over b minus a is exactly the same as dividing by b minus a. When we do the integral portion, we're adding up function values of the function. And then the b minus a part is we're dividing by essentially the number of values that we added together. That's one way to think about it. Another way to think about it is when we have an f of x function, the integral represents the area from a to b. So if we take the integral, which is the area from a to b, and we divide it by the length of from a to b, which is b minus a, oops, I can't spell the word length right now. Oops, and that's not an eraser. Oh, it's just going to be one of those days. Making a video. So we take that area value and divide it by what this length is, we'll get sort of an average for all the height. If we took all the heights and we added them together, all the little rectangle values and added them together, divided it by the number of rectangles we had, we would get an average. It's a little easier to understand with a problem that has a context versus just a function. I'm going to show you an example here with just a function. I'm going to do example 1, and then I'm going to leave examples 2 and 3 for you to try and check your answers, and then we'll do an application problem on the back. So these will be easy to know that this is what you're doing because it will literally say find the average value of a function over an interval or between two values of x. So a is 0, b is 6. So the way we're going to calculate this is we're going to take 1 over 6 minus 0 times the integral from 0 to 6 of my f of x function. That's really the only new part of the problem, because everything we're going to do next is a fundamental theorem problem, which is calculating this total, and then we're going to divide by 6, or that's the same as multiplying by 1 over 6. So we're going to end up taking 1/6 times big F of 6 minus big F of 0. Get my mouse here for a second, and let's grab some stuff and alright, let's grab that. Squish that down for a second. Okay, so here we go. Little f, 2x plus 4. Big F, antiderivative, x squared plus 4x technically plus C, but we know when we do fundamental theorem that the C essentially subtract away. So to do my average value, I'm going to be doing big F of 6 minus big F of 0, and then multiplying by 1/6. So let's see, that's going to be 36 plus 24. This is 6 squared plus 4 times 6 minus a bunch of zeros when you plug a 0 in. So 1/6 times 60. And so that's the average value is 10. It's a coming together of a total. That's what the integral does. It gives you the total change. And then we divide it by or multiply by 1 over the interval time. And that tells us the average value. At this point, I would say stop the video and maybe try problems 2 and 3. And then when you come back, you should be able to look at the answer key and see correct answers for those. All right, if we move to an application question, like I said, I think an application question is a little easier to understand, especially when we combine it with what we just talked about last class. If we're going to find average change, essentially we're going to calculate a total change divided by the interval of time that the change occurred over. So in this case, I want the average change between months 3 and 6. So I will calculate the total change between months 3 and 6, and then divide it by 3 months, which is the same as multiplying it by 1 over 6 minus 3, or 1 over 3. So we're going to end up with 1 over 3 times big F of 6 minus big F of 3. Nothing different about how we're approaching the problem, but a definite difference on sort of maybe understanding what exactly we're calculating. Oops, I don't want to write. That's not what I wanted to do. Let's undo that. Let's grab my grabby thing. Let's grab this guy. Let's take him where I've got some space. Oops, or not. Hello. It's thinking. Okay, there we go. All right, so FTC work is where we start. Little f to big F, antiderivative work. 3t minus 1 plus square root of t is t to the 1/2. So big F, 3t squared over 2 minus t plus what's going to end up being 2/3 t to the 3/2. This is going to be a little bit of a messy problem because we're going to be plugging a 6 in and we're going to be plugging a 3 in, and we've got t to the 3/2. That's like the square root of something and then cubing. 6 and 3 don't have nice square roots, so these are not going to be nice numbers. We're going to get decimal numbers. Okay, lots of little things you can do with your handheld calculator to help offset the calculation issues. Okay, if we do a little bit of the storing trick, like with our big f of x here, I want to plug a 6 in. So let's say I take a 6, store it for x. Great. And then if I want to type what my antiderivative looks like, and I'm going to use x's even though it's written in terms of t. As long as you're consistent with your variable, your calculator really doesn't care. We'll make it a fraction. Now, when you've got these fractions times variables, you can do a couple different things. You can put the variable up in the numerator, or you can put sort of the fraction out front of the variable. So you can see my 2/3 x to the 3/2 I've done, and I've done this one a little differently. Just two different versions. I could put this x up here with to the 3/2, works the same way. Now if I've got that and I press enter, what's happened is my calculator has replaced all the x's with 6's and done the arithmetic for us. 57.798. So 1/3, 57.798 minus. Now the nice thing about this is if I just do a new store, -3 stored, or not -3, just 3, -3 stored for x. If I do a second enter, do a couple times till I get back to the expression. Oop, I clicked it more than once. It will redo the calculation with the 3 in there. Oops. $13,964. So I'll finish that one. Cheat a little bit. 7.798 minus 13.964. About 43. Divided by 3. Times 1/3 or divided by 3 gives me that 14.611. Now context is important, so let's go back. What was this problem about? Where my cursor is, there it is. Change in earnings in dollars per month. So the total change was 43.83834. Dollars. And then when I divide it by 3 or multiply it by 1/3, it means that that total, if we broke it down over 3 months, that total we would be looking at coming out at about 14.611 dollars per month. Make sure I'm not missing any millions or thousands. Oh, thousands. Okay, yeah, that sounds a little better. Okay, let's say I didn't think it was in just dollars. Oops. So let's pipe back up to that. about 14,000 per month, about from a total change of 43,000. The other application problem, I will have it worked out for you. So you should go ahead and do the 2 problems on the front and the 1 problem on the back, and then check your answers and make sure you are able to get everything done accurately. All right. Give it a shot. Thanks.